When we're looking at right angle triangles, so let's just draw any right angle triangle here. So right angle triangles, one angle has to be a right angle, and obviously for the three angles to add up to 180 degrees, these two angles have to add up to 90 as well, so they each have to be less than 90. If we put A, B and C, so opposite angle C, which is a right angle, will be side C, opposite will be side A, and opposite B will be side B. Pythagoras worked out that if we square B, we square A, and add those two together, we get the square of C. Now another way to write that is that C squared equals A squared plus B squared. So that goes for any right angle triangle. It has to be a right angle. This is called the hypotenuse. The hypotenuse squared is equal to the sum of the squares of the other two sides. So the square of A plus the square of B is equal to the square of C. Now, if you like, you could prove Pythagoras' theorem. So we've got B, we've got A, and we've got C. If you drew a right angle triangle, any side length, as long as there's a right angle, and then we drew a square, that would be C by C, and we drew a square here, which is B by B, and then we drew a square there, which would be A by A, so it's a square. All those would be right angles in each of those. We could actually cut those two squares out, or cut the three squares out, and then put A in here, and then we could cut this into strips and use those strips to fill up the outside, and you would find, so this would be A by A in here, and these would be strips in there, and you'd find that A squared plus B squared equals C squared. So there's a little proof of Pythagoras' theorem. So it's quite powerful because it means that given any two sides of a right angle triangle, we can calculate the third side. So let's have a look at a few examples. Say we're given a right angle triangle, and we'll just draw it a little bit differently here. And we know that this is 3 and this is 4, and you're asked to find the value of the extra side. So we'll call this C. Doesn't matter which one you call A and B, we'll call that A, we'll call that B. So you know that we start by quoting the rule, which is Pythagoras' theorem, C squared equals A squared plus B squared. C squared equals, now A is equal to 3, so that'll be 3 squared. B is equal to 4, that's 4 squared, equals 9, plus 4 squared is 16, equals 25. So that's C squared, so C will be equal to the square root of 25, which is equal to what times itself gives us 25, or 5. So C is equal to 5 units. So if these are centimetres, C would be equal to 5 centimetres. Okay, that's when we're trying to find the hypotenuse, or the longest side of the triangle. Hypotenuse is always the longest. Now if we've got, say we've got the hypotenuse and one of the other sides, so we've got 6 and we've got 10. Now we're asked to find the other side, so we're told this is a right angle. Once again, we can name that equals C, this will be equal to A, and this will be equal to B. And say they are meters. So we know that c squared equals a squared plus b squared. Now we want to find b, so we get this by itself. Now the a squared, we take it over to the other side, and when we do that, we'll actually, it's a plus on this side. When we take it to the other side, it becomes a minus. Now if you'd call this a and this b, the corresponding one for a squared equals c squared minus b squared. So we use these two when we are given the hypotenuse and one of the sides, and we've got to actually calculate one of the other sides. So you'll either use that one or that one, depending on how you've named the sides. Okay, so we're going to use this one here because we want to find b, but we find b squared first. So c squared is 10 squared, a squared is 6 squared, and that's equal to b squared. 100 minus 36 equals b squared. 36 from 100 is 64 equals b squared. From that we find the square root to get b, so b equals square root of 64, and that's equal to 8. In this case it was meters. So two examples of Pythagoras' theorem, one where we know the two sides and we need to calculate, let's get back there. One where we know the two sides and we have to calculate the longer side or the hypotenuse, and we just use c squared equals a squared plus b squared. And the second example here, these only apply to right angle triangles, is when we've got the hypotenuse, we've got one of the sides and we have to calculate one of the other sides. Well, we need to use either this one or this one. There's a minus in it, which is different to the other one. And that will allow us to work out one of the sides. So don't forget to take the square root at the end as well. There are what are called Pythagorean triads. And there's probably 3 of them or 4 of them that you need to probably try and remember. One is 3 is to 4 is to 5. 5 is to 12 is to 13. 7 is to 24 is to 25. And 8 is to 15 is to 17. Now, what's the meaning of this? These 4 triads actually crop up quite a lot in maths. If you've got a triangle with a side of 3 and a right angle triangle with a side of 3 and a side of 4, using this triad, 3, 4, well, the longest side has to be 5. Now, it's not only that, but it's any multiple of those. So if you were to multiply each of those by 2, we've got 6, 8, and 10. So a triangle with 6, 8, and that one will be 10 will work. So it makes it a bit easier. Same with these. So you can multiply or divide. So we could multiply this by 2, and you've got 10 is to 24 is to 26. So if we've got 26 there and 10 there, so that's the hypotenuse, the longest one. This is one of the sides. Well, this must be 24. Right angle, obviously. So these triads, particularly these two, but these two occur often as well in mathematics. So the Pythagorean triads.